When we have an individual computer, like Bob's computer at his home, and we want to protect that traffic as it goes up to the corporate network, we can implement a remote access VPN, and that's the topic I'd like to focus on with you in this nugget. So there's lots of reasons and circumstances where we might need a VPN for a user like Bob. Let's think of those. Maybe Bob goes home in the evening and he's at his home connected to the internet, and yet he still wants to connect to corporate resources. Or maybe Bob's at a convention. So there's lots of reasons why we would want to protect Bob's traffic as he communicates with the corporate headquarters or with one of our remote sites. And so if we want to use a VPN for Bob in that situation from his PC, we would use the remote access flavor or category of VPNs. And regarding the software on Bob's computer that's going to create and build that VPN, let's imagine that we have up here off corporate, let's imagine we have a firewall that's acting as the head point or termination point for VPN services for remote access VPNs. And that could be either here at the firewall, or it could be at the router, or some other dedicated VPN device. And so the choices that Bob has is Bob could use a client, a VPN client that's built into his operating system. So he was on Linux or Mac or Windows. Those platforms have some capabilities and functionality for building VPNs. And so Bob could use one of those. Or in a Cisco environment, the best option for Bob's remote access VPN is the Cisco AnyConnect client, which Bob could install on his computer and use that software as the logic behind building that tunnel between Bob and the head end device. So that'd be Bob's personal VPN right there going to corporate headquarters. Now, with cryptography and VPNs, we're going to be using encryption to make the data private. We're also going to use some type of hashing to help verify the data integrity, as we've discussed in previous videos as part of this skill. And most of the time, the details for what type of encryption and hashing are going to be configured on the head end device, and then the client, when it connects, they'll negotiate what they're both willing to do and build the VPN based on what they both agree to. So some of the options for remote access VPN include using SSL/TLS. SSL is the old flavor of it, but TLS is transport layer security. That's the technology that we use when we go out to a secure website. So we're going to a banking website. The URL looks like https:// something. And behind the scenes, it's using encryption and authentication to build a secure connection. So SSL/TLS can also be used for remote access VPNs as well. Now, one of the problems with SSL/TLS is that it's TCP based. Now, at layer 4, TCP is great. However, there is some overhead with all the acknowledgments and everything else to verify the segments all made it back and forth. So one other option that VPNs can use is a feature called Dtls. And Dtls is an acronym for Datagram Transport Layer Security. And the biggest difference here is that it uses UDP, and that has less overhead. So by sending most of the data via UDP with Datagram Transport Layer Security, we're removing some of that overhead from TCP to have more efficient communications over the VPN. And depending on our client, other options may include using IPsec, and some clients support IKE version 1, some support IKE version 2, or both. And IPsec is a suite of protocols typically used for site-to-site VPNs, but also can be used by many VPN clients. There's also protocols like PP, TP, and L2TP. They have their strengths and weaknesses, but I just want to point out there's several options that can be used when implementing remote access VPNs from a client going up to a head-end VPN server. And let me share with you one more really important aspect that's important to understand regarding remote access VPNs, and that is the concept of split tunneling. Without using split tunneling, when Bob initiates his VPN, all the packets that leave his computer are going to go through the VPN up to the firewall, in this case, acting as the VPN head endpoint, and then being routed where they need to go. So if Bob is going to ESPN, or he's going out to Twitch, or some other really fun site, that traffic would leave his computer, go up through the VPN, hit the firewall, and then the firewall would have to reroute that out to ESPN or Twitch, depending on the destination of where that packet was destined to go. And here's a good analogy of what that might feel like or look like. Let's imagine we want to go talk to our neighbor next door. To talk to our neighbor, we go down to the supermarket, and then from the supermarket, we walk over to our neighbor's house. Then when we're done, we leave the neighbor's house, we go back to the supermarket, and then back home. It's an extra trip. If we don't need it, we shouldn't have to do that for all of our traffic. And that's where split tunneling comes in and avoids sending traffic through the VPN if it doesn't need to. And here's how we control what traffic goes through. Let's imagine that up here we have the 10.16.0 network with a /21. And that's all of this address space up here. What the administrator would do is configure the VPN server up here, this head-end device, and tell it, you know what, when you get a new VPN client, go ahead and send the instructions, only tunnel traffic destined to 10.16.0.0/21 in that address space. So if Bob's going to ESPN or Twitch or anywhere else that wasn't 10.16.0, that traffic would just go directly there to those servers and wouldn't be sent through the VPN tunnel to the corporate site. So the idea of split tunneling is specific instructions on which traffic, based on IP information, which traffic should go through the tunnel and everything else shouldn't. And I would like to share with you one more insight on why we might want to send all the traffic through the tunnel regardless of where it's going. If we have network devices, security devices, and appliances at the headquarters site that are analyzing all the traffic, looking for malicious websites and everything else, if we force all the traffic through the VPN tunnel, those checks and those security measures can be taken even if Bob is going to Twitch or ESPN or somewhere else. So there's pros and cons for split tunneling or not, but the concept is split tunneling says only send specific traffic from the remote access client through the VPN, and everything else, go ahead and send it normally. So in this video, we've taken a look at some concepts regarding remote access VPNs that allow an individual computer to connect to a VPN server. And that VPN server could be a firewall, a router, or some other dedicated device that's built to handle those incoming remote access connections. In the next video, I'd like to walk you through some examples in the interface of some VPN clients, including those from Windows and also AnyConnect from Cisco systems. So I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.